Alright, in this video, I'm going to show you how to create a program for binary search and linear search. So first off, let me show you the inspiration. So this is the code. It's not my code, but this is where I got the idea of creating a binary search. Alright, so I did modify it just a bit, just the font size and position, so you can clearly see it. So you can type in a number and then press enter, and then it filters through and then searches for, and then it sees if it's not, you can reset it. Right, and then I thought this idea was very unique, and I really liked it. So I wanted to create something like it with a binary search, but rather than this complex code, I created something a bit more simplistic and more easier to read. All right, so let me show you the how this code works. So we run it real quick, and then look at the terminal. We see that a random list is generated, and then it first categorizes it as either sorted or unsorted. Remember, when you're doing a binary search, the list has to be sorted. So it has to go from smallest to greatest, and that's going from left to right. So it has to go from, like, for example, 1, 2, 3, 4, 5 from left to right. And but for linear search, the unique thing about linear searches is that the list doesn't have to be sorted. It can be sorted, it can be unsorted, but the thing is, when it is sorted, it's faster to use a binary search because it immediately removes half of the list to find the number that you're finding. And then it generates a random number that it wants to find within the list. And then it calls for the item, and if there's duplicates, it gives you the the positions of each item within the list. So for example, we see 3 here, and we see 3 here. And then always remember, you don't count from 1. You start from 0. So this goes 0 and then 1. And then it's in the 1 index position. And then 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and then it's in the 11th position. However, if you are taking AP Computer Science Principles, I'm not sure about AP Computer Science A, but I know with the list, you start off with 1, which is completely different to like actual coding where you start with 0. But just keep that in mind for the AP exam if you're taking the AP exam. But okay. All right, to make this easier, I decided to just open up a new tab. So, to begin, we're gonna create the binary search. So let's create a function. Let's just name it binary search. Yeah, binary search. And then we're gonna have to add parameters where we're gonna add sequence and item. And then we'll use these parameters to iterate through the list later on. And then we're gonna begin index. Index equals 0, and then end index equals the length of the sequence minus 1. And then now we're going to create a loop, a while loop to be exact. So while begin index is less than or equal to the end of index, the midpoint is equal to begin index plus end index minus begin index. And then we're going to divide that by 2 because remember, a binary search will first start off, so it'll recognize the number and then look at the midpoint, the middle point of the list, the middle number, and then decide is the desired number greater than or less than that. And if and then basing off what it knows, it'll divide the list by 2. It'll divide it by half. Okay, and then midpoint underscore value is equal to the sequence of the midpoint. All right, now that we got that, we're going to create a conditional statement or a selection. So value is equal to the item. Then we're going to return the midpoint. And then another selection, an elif statement. And elif, if elif item is greater than the midpoint value, then we're going to do index. The end index is equal to midpoint minus 1. By doing this, we'll be able to reiterate, like continue iterating. And then we're going to create our end of this part by doing an else statement. Else begin index is equal to midpoint plus 1. So this is the basis of our binary search, right? You can add comments, right? Comments or documentation is very important if you're giving credit uh, to parts of your code that's not created by you. And yeah, if adding comments helps you with memorizing what certain parts of the code does, go ahead and do so. And then we're gonna add a return. Return minus 1. So this is basically if it's not able to find it, it'll just return -1 and then it'll just perceive as error. Do the linear search. So we're gonna once again create a function. So search sequence. So it's important to use the same parameters as the one you use from the binary search because it still will use up the variables from the list, but it'll just categorize it on different basing if it's sorted or unsorted. So make sure whatever you have as sequence are the same for both procedures. So yeah, and then we're still gonna have item, and then in this, so this is gonna be an empty list. You can really name it anything, and then this is where we iterate. So for I, you could use I or I just use I because it's like wait, what's widely used in Python. Range and length, and then sequence. Oops. Okay. I, oh, I was like, oh, yeah, it's my bad. Sorry. Yeah, there you go. Brian range. Yeah. If sequence of I, so if we're searching through the sequence of the I, if the item in the sequence of I is equal to the item, then oops, then we'll return that. Okay, and then we're gonna, yeah, and then we'll import random with our functions or procedures. Now we're just gonna create the actual callings and variables of everything. So this is why I said the parameters for both our functions are important to have the same. Because here we'll have sequence is equal to random. You can do random, or you can actually create a list, or in fact, you can make the user type out a range of numbers. It can be greater than or less. It can be sorted or unsorted, because the this following program will categorize it as such. So that's just a way to make it more user interactive. or you can just make it randomly choose. So basically, what we're doing here is with range in 121. So this creates a list within. So here, wait, let me finish it. So k equals 15. So k15 means we have a list with 15 elements, and each element will be given a random number between 1 and 21. So there's an equal possibility to get the number 1 for the first element, and the same opportunity to get 13, right? And this just basically chooses the range of numbers that can be the possibility, and then this can be the amount of elements within that list, right? And then we create item. So this is the item that we're searching for within our list. Random dot choice and then sequence. Okay, and then we're gonna print uh, print. Let's say OG sequence, right? And then plus. Oh wait, is it plus? No, 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 it's not plus. Sequence like that. Okay, and then we're gonna do selection if all sequence with I is less than or equal to the sequence of I of I plus 1 for I in range of length time, I mean sequence minus 1, like that. And then we're gonna print. I guess you could. Okay, yeah, we'll do that. Print sequence is sorted using binary search for item and then item, and then we'll call that function, and then here's where we call it sequence. Sequence.item, like that. Okay, and then if result is equal to -1, as we did it, right? As what we did as the result if none of this works, we're gonna print out item is not in the list. We'll add a little sad face. Okay. Else print. Oops. I what? There we go. Else print item found at index results, and that's where we call it, right? That's where we call it here within this variable, and then prints it out. And then else, right? Else if it's not sorted, we're gonna print sequence is not sorted. Using linear. Using linear search. Search dot item, and then results equals search sequence item, and then okay, and then if result is equal to -1, right, as we also did, right? Oh, no, we didn't do this one because it'll just occur an error, right? This will just be an error. So we can, right, do like a return. Oops. Wow. Return -1. We can do that, but either way, it'll just result in an error. But yeah. Okay, let's see. Okay, so if result is -1, then we're gonna print out the same thing. Item is not found. Uh, yeah, item is not found in the list. Okay, and then if after doing all that selection, we're gonna print we're gonna print item found at index, and then we're gonna do results. Okay, now let's run it. After reviewing this code and actually trying to test it, there are two mistakes, and they're both syntax errors, not logical errors. So one is that in line 29, it's missing an S. Such a small mistake, and the whole code would just not work, right? And then another one was that we're supposed to return, and there you go, return. We're supposed to return after doing that. Because if not, this whole code is just useless. It's not giving us anything back. So now if we run the code, there we go, right? So it gives us the OG sequence, the original sequence, the randomly selected, the randomly generated sequence, and then it categorizes it as not sorted, and therefore, because it's not sorted, we're going to use a linear search and look for the number 13. We see 13 right there, nowhere else. So, and remember, we start at 0, 1, there we go, 1. Right, and then let's say we were to change this to an actual list from smallest to greatest, right? 1, 2, 3, 4, 5, 6, 7, 8, and 10. We run it, and there we go, right? The sequence is sorted, and then, there is a spelling mistake. My bad. Let me just, there you go. There you go. But we see that it is sorted, and it does recognize that it is sorted. So therefore, we're going to use that binary search and look for item 9, and we see 9 is there. But yeah, that's pretty much the code. Pretty simple. You can use this for the create task, although if you are going to use it, make sure you modify it so you're not um, completely using it off the internet, you know, just for your sake, right? I mean, I also did take some parts from the internet. Like I learned how to create a binary search, but everything else was I just kind of was just messing around and then did all this kind of stuff. But if you like the video, like it, subscribe, share to your friends, please and thank you. Anything helps. And yeah,